Perfect. Okay. Thanks for joining us, folks. This is our second office hours session. And today we're going to talk about async processing and various patterns in Node.js. Standard safe harbor statement here. Don't make any purchasing decisions based on what I say today, although I don't intend to show you anything you can't already do today. With us today is Chris Jones, as well as Blaine.
Howdy.
How's it going, guys?
Cool. Good.
I have a couple items to talk about in terms of news and announcements, but I'm going to let Chris actually talk about both of these. So what do you want to say on these, Chris?
If I can read them on your small screen on my, let me zoom in. I've got you.
Is it really tiny?
Yeah, no, that's fine. So actually there are three announcements, only two here, because I didn't tell you the third one. So GitHub IO pages. So for a long time, we've just referred people to the github.com source code repository to read the documentation from a file called api.md. We've just moved that across to this GitHub Pages site, which is just, for those not used to GitHub, just a site they automatically create for us with a click link. And so this is now what I'm going to refer to as the sort of main home for Oracle documentation. And there's also if you go back up a couple of levels there, there's also the the official homepage on that site. So we're going to start moving all the links across to this, and hopefully people will start using this for doc. One thing which I didn't get around to drawing a diagram for, but I'll explain very briefly, is that this will then let us push changes to the source code repository into documentation there, but not into the documentation Dan was just showing you on this .io page. And that means that users with Node, which you've kind of got and running with, will just refer to a sort of steady version of the doc, which is consistent with the version you're running, whereas back in development land, in the source code repo, we're busy pushing in changes and things which you may not immediately have available or may be incorrect or whatever. So that's kind of just one of the reasonings there. Plus also the GitHub IO pages just makes everything easier, and we've got similar pages for other drivers as well.
Cool.
So the second point you had there on that slide was, oh yes, so Yum repository. So anybody using Red Hat, Linuxes, CentOS, things like that, can now get packages from us for Node itself. And there is actually, if you really wanted, an RPM package for the Oracle driver. I think they're just a little bit behind at this stage, but I know they're working really hard. They're pushing out 1,000 billion packages out there to make everything available on the one repository, including something Linux people know as the EPEL packages. So there are a couple of thousand packages there. So they're just busy pushing a lot of stuff out there to make Oracle Linux easier for users. And then the third thing which wasn't mentioned there is I actually did create a kind of Skunkworks Facebook group. So, in Oracle, we have lots of processes, mata. So there is a Facebook group out there which you can search for, and I'm just pushing out a couple of, release announcements, things like that. Effectively a kind of Twitter feed, but on Facebook, because I know that Facebook gets used in some places more than Twitter. So if you want to go and search for content on Node.js, JavaScript, Oracle Database, Python, PHP, all of the sort of scripting things that our group looks after here in Oracle Database world, just go onto Facebook and search for that, and you can find it.
Excellent.
That's it. Thanks, Dan.
Did you have a link on that last one, or?
Yeah, I did. I will shoot that through to you in a few seconds. Hang on.
Okay.
Let me pop that up. And I'll just put that on the chat. There we go. So Zoom, for people who are not familiar with it, does have a kind of chat feature, and you might see something a little bit flashing on your screen at the moment.
Oh, cool.
Just take you to the chat side.
I had not seen that yet. I'll have to get into that. Yeah. Excellent. All right.
Share and enjoy. Obviously, it's an open forum, so just be polite, etc., etc.
I'll do my best.
Yeah.
All right. So let's go ahead and get into today's topic. And I'm just going to try to keep these slides open like this. I don't want to go full screen and have to toggle back and forth. But if it is difficult to see anything, just let me know. Give me a heads up and we'll take a look at it. So, of course, I'm assuming that everyone here knows what Node.js is, so I won't get bogged down into that too much. Oh, and another side note, if you have any questions at any point in time or you want to explore something further, just shoot me a message in chat and I'll do my best to keep an eye on that. You don't need to wait to the end or anything like that. So basically, Node.js was created back around 2009 by a guy named Ryan Dahl. And at the time, what the project was all about, the problem that they were trying to solve, was doing networking efficiently, because generally up until that point, the way you would handle network requests that were inbound is you would accept the request and then potentially spawn many processes, perhaps writing to files or communicating with a database. And while those processes were doing that kind of work, the process that's handling the connection would stay open, and this model just didn't scale very well at all. And that's where concepts such as event loops came in, and Ryan Dahl was looking at applying JavaScript to this entire new world. And he found JavaScript to be a really good language to do this with. And what? My images can't be displayed. Let's see here. Oh no. Boy, oh boy, well, that's a bummer. I'm not going to try and debug all this right now. What I'll do instead is just kind of talk to these points.
Sure.
All right, so basically with functions as first class, the idea was JavaScript just offered this out of the box. And the idea was, it had to do with the fact that it was created to handle this very thing from the very beginning. So when we look at a very simple website example, as I have here, let me blow that up some. So what we're looking at is a typical scenario where we're just in the body of a web page. We see a button and we have a script tag, so we have some JavaScript in the page. And what we're doing is declaring a function called onload. And onload inside of it has another function called onClick. And so when we're talking about first class, the idea is that unlike some programming languages in JavaScript, when we have a function, it can be treated just like any other variable. And we needed this ability because of the dynamic and asynchronous nature of JavaScript from the very beginning. In this case, we're seeing an example where we take the button and we register an event listener on the click event. And you see this pointer here to the name of a function which was declared above it. So this is one of sort of the two ingredients you would need to get async work done in JavaScript. And that was supported for quite some time. And the other one is known as closure. And so with closure, what we needed was the ability to have a function within a function. In this case, the onClick function is declared within onload. And you see that onClick within that function, it's referring to the variable declared in the outer function scope. And so this is basically, in some different languages, like say PL SQL, for example, which is my background for the longest time, something like this just wasn't possible. When the onClick function eventually ran in the future, when the click event occurred on the button, this function would not have access to that outer reference of the button because the onload function would have finished running long before then. But in the case of JavaScript, JavaScript goes ahead and ensures that when an inner function is referring to a variable declared in the scope of an outer function, that it can maintain access to that going forward. And so you had these concepts that are already built into JavaScript. And what Ryan Dahl started to do was apply those then to networking, which is where Node.js came from. That's sort of the background on that. Despite that fact, this is probably my only image that's working, even still, even though JavaScript is sort of known for being able to work with events, when Rising Stack ran a poll recently to find out what developers love about Node.js, speed of development obviously ranked rather high, but absolutely dead last was this asynchronous coding. And the reason for that is, of course, what we're talking about today. There's basically lots of different ways to do it, but it really wasn't until recently that we got to a point where asynchronous development is finally getting easier, and that's thanks to async await and the JavaScript gods doing some really complex stuff behind the scenes for us to make the code that we write a lot simpler. So these slides here, I pretty much talk about some examples that I'm going to run through and some of the patterns we'll be using. The Node.js pattern, which I'll just talk about in code instead. There are some basic async flows that you'll find yourself needing to code from time to time. The first of which is a sequential flow. This is where you're doing various tasks, and before you can go to the next task, the first task has to complete what it's doing. And another type of flow might be if you're doing something in parallel, and then of course you might combine these types of flows depending on the workload that you're trying to handle. And I wanted to look at a couple different flows, the first of which being a scenario that I think is rather typical in enterprise-style development, header detail transaction, where you insert a header record and you need to get back the primary key ID before you can continue inserting detail records. And another one I want to look at is sort of a different style of development or writing asynchronous code, which is doing some kind of ETL via stream. So we'll take a look at both of those. But before I continue, I did want to address his question in the queue, what is currently supported for rack service, FAN, and FCF. I know you're working on application continuity, but not sure what else is currently supported. I'll let Chris tackle that one.
Yeah, this is an interesting one. So Dan mentioned the future things. We have the event flag. How do I explain this, especially for people who don't know what's going on? Oracle client tools, Node, Oracle DB, Python, etc., can listen for events from the database. So these fast application notification events. The session pool, the connection pool that we use in Node Oracle DB can handle these events in certain ways in terms of closing dead sessions if a database has disappeared in the back end, automatically reconnecting to another database. So Rack is a clustered database that we have. And so typically you might have a cluster of a couple, 3 maybe, sets of processes running the database, accessing the shared database files. And if one of those sets of processes is gone, one of the database instances, then the other 2 can continue doing work. So the session pool will be able to reconnect to one of those surviving instances to make sure the connections are available for users in the application. So we effectively support anything that OCI supports with provisos that it's through the session pool. So you can already use this events flag. There's an Aura_events environment variable you can set to turn on this event listener so that Node Oracle DB is listening for those events. You can also set it through the Aura access.xml file, which is actually documented in the Node Oracle DB manual. And then in 2.2, which is upcoming, we've just exposed an extra Oracle DB.events attribute, Boolean true false, just to enable this events mode so that the Node Oracle DB processes are listening for these events coming through. And then effectively it's the FAN and the failover that we're targeting for that. And there's something also called runtime load balancing, which will work with the session pool. So I think I'm going to leave it there. That's quite a complex topic to go any further, but effectively we're listening to the events, and as long as the database is configured to send the events, then we're just behaving like any Oracle call interface client, C client.
Excellent. Thanks, Chris. There's a follow-up question. Let me see if this is related. Events will only trigger if they're in Aura access XML, correct?
Yeah, the flag is Aura. Oh no, sorry. Hang on. Am I confusing it with? Yeah, sorry. I was confusing it there. It's early in the morning for me. I'm not that early. I was confusing it with the addition flag, which also will be coming. We'll have native support for enterprise-based redefinition, which is the PL SQL versioning, so you can access different versions of PL SQL objects, and that does have a environment variable called Aura_addition. Sorry, I'm conflating the two things together, so apologies for confusing you there with the environment variable. But for the moment, you'll need to use our access.xml, which means you need a version 12 client library, Oracle client library. When we push out the next release 2.2 of Node Oracle DB, then we'll just have this extra property, which you'll be able to set just to make it a little bit easier.
Excellent. Thank you, sir. So continuing on, this is the first scenario we'll be looking at, which is just a simple header detail scenario. And so I want you to imagine that we have some kind of REST API, maybe listing on domain.com/API/orders, and we're going to accept some post requests coming in. And the order that we'll be processing is this guy right here. So just a real small order. So obviously the name here is for the parent thing, and then you have a detail array with several child things that you need to get into the database. So that's the basic scenario. The first pattern I want to explore is the header detail and handling the incoming request using anonymous callbacks, which is oftentimes where Node developers tend to start in the very beginning. And so we have that pattern here. Just reorganizing a few windows. Okay. So what you see is I'm bringing in the driver, and then I have a function here called post, and the post is going to take in that order that we saw a minute ago. And eventually, when everything's processed or finished processing, it'll invoke this callback function and either A, pass along the error that occurred during processing, or B, return null for the error and then the header ID that was inserted. So the very first thing we do is we go to the driver, we get our connection, and this is that Node.js style callback pattern that I was describing earlier. So basically, the way that it works, sort of two things need to be true. First of all, the last function that you're passing into an async API, in this case, get connection is the async API. So the last parameter passed to that function would need to be the callback function. So if we had any other parameters, they would be in front, like 1, 2, and so on. And then in that callback function, the first parameter is reserved for errors. So the very first thing we need to do is check to see if any errors occurred. And if so, this return here becomes really important, as we want to short circuit the logic and not continue processing if an error occurred. And this is just how it worked with the Node.js callback style pattern. So we get our connection. If you get to this point, you can assume success. So we can then use that connection to execute, in this case, the insert statement going into our header table. We see here an example of using some bind variables. So we're binding the value of name in, but the ID is actually a bind out. The type is number. Passing along another callback function, this time to handle the success or failure of this async insert. And so we have, again, some error handling logic in the beginning. We do have to close the connection even if an error occurred, and then eventually send back the signal as to what error had occurred. But if we get to this point, then you can assume success, that your insert succeeded. So you can get the ID out of your out binds and assign that to a variable, in this case, header ID. And then we can start inserting detail records. Now, using anonymous callbacks, this is where things tend to get a little sloppy, and we're starting to see some of the weaknesses, if you will, of anonymous callbacks. So if I come down, you see the first detail record being inserted. Further along, you see the second. And further along, you finally see the third. And in addition to this nesting and hard coding of these callbacks, and hard coding meaning that it's not able to handle a dynamic number of detail records because it simply couldn't. There's no way of handling it with anonymous callback functions. If you come to the very bottom, you'll notice this shape starting to take place here. And this is something that sometimes developers call the pyramid of doom, or there's different names for it. But in any case, we've fallen for it here. And so new Node.js developers often end up here and they kind of pull their hair out like, why is Node so hard? that's sort of like level 1. So the good, it actually does work, and I can prove this actually. So if I come here to SQL Developer, if you look at this header row, we currently don't see any data in it. And if we open this directory up in a terminal, what I have is a test file here. And so what the test file does is it brings in the driver. It first creates a connection pool. And if you saw the DB config here, you'd see it's just one single connection. But I do prefer to write the examples using connection pool so people get in that habit. And then depending on the additional flag that's passed in, it'll pull out whatever test it needs to, run the test according to its API, and then log some of the results. So if I run this, with node test, and we run the first test, you see it pulls out the header detail with anonymous callbacks test. It runs that, and it gets back an ID of 35. We come back to our header row, we see our parent thing, and then if we look in the detail, we see all the detail rows for that header record as well. So it works, but the bad, of course, is that we fell into the pyramid of doom. We're unable to handle the arbitrary collection lengths coming in. It's obviously very hard to maintain, and of all the solutions, this one by far has the most amount of code despite being the least flexible. So we're up to about 118 lines of code. Cool. Let's move on and see if we can do better. So as Node developers get more comfortable with JavaScript, they eventually stumble upon named functions. And you're seeing here the 30,000-foot overview of what's happening. So here's a function called post, here's one called create order, and here's one called create details. So we're starting to sort of separate out the work some. And if we look at our named function example, you'll see overall we're down to about 94 lines of code, but things do start to get a bit better here. So we've taken the post just like before. We have the order as well as the callback that's eventually going to be called back or invoked when the operation succeeds or fails as a unit. We have very similar patterns in terms of the callbacks and checking for errors. That hasn't really changed at all. But what has changed is inside the post, we have this other function here, create order. So rather than continue to nest and nest and nest and nest, now we can pull this out a little bit and invoke another function, in this case, a named function called create order. Because we're no longer nesting, one of the easy things that happens with the anonymous callback pattern and just unlimited nesting is that scope management is maybe a bit easier because you can always refer to parameters and variables and higher levels of scope. But in the case of separating out your named functions, you now need to start to pass the scope around. So if in the post handler, if this is where you get your connection, and then you want to invoke create order, you're going to have to pass the connection along that create order should be using. So a little bit tricky there, but I think the benefits definitely are a good thing here. So here we move into creating the header record. Same binds as before, same error handling as before, but now we get our header ID. And this is where things get a little bit interesting because the named functions can handle these arbitrary collection lengths. So you see I'm invoking create details once and passing along some state, as I mentioned before. But in create details, notice that I'm passing in 0 for the index, meaning that we're at the very first record of the details that we want to insert. And it's not until that value reaches the length of the array that we're trying to insert or work with here that it will go ahead and short circuit and complete the operation. But as long as that's not true, then we'll insert a detail record. And down here, you're seeing an example of recursion, a manual implementation of recursion, where I'm calling that same function again, and I'm just incrementing the index by 1. So we can come through here, we can iterate 3 times, and that's why we see that reduction in the code overall. I won't belabor this much more after this, but just to prove that it's working, we can run that, come back to our header row here, and we'll see the next one coming in. So I won't continue to prove that each of these does work, but in fact they do. So the good here, obviously less nesting, we're handling arbitrary collection lengths, easier to read and maintain, but on the bad side, I don't like this really tight coupling that happens and the fact that you then have to pass data around. This is just the reality. And of course, the manual recursion was not great. So the next pattern I want to look at is the async module. And the async module is by far one of the most popular modules that was ever introduced into the Node ecosystem, or NPM. So to install it, pretty straightforward. You just do an npm install async and then save that. And once you have that module installed, you get access to, I believe, over or close to 120 methods and utility functions. And they're grouped into 3 different groups. The primary groups are the 2 here, collections and control flow. And collections are a set of methods that are available to you for working with arrays, essentially. And then control flow is something similar, but working more for the structure of your code. So you'll often see the names are similar and they use similar patterns. It's just exactly how they're used within your code can vary a little bit. And one of the powerful things about async is that it has really handy methods such as this one here, like queue. And in fact, just today I was in the GitHub issues tracker talking with somebody about maybe using this particular method because it's there and it's easy and straightforward to use. You don't have to reinvent the wheel when you want something like a queue. So this is what it starts to look like if you go ahead and use the async module. And this isn't a complete story. So let me show you what this same transaction would look like using the async module. So the first thing to note is that we're bringing in async, and I'm calling the series method, which is one of these control flow methods. So in terms of control flow, what we're saying is there are a series of functions that I want to execute, and I want to execute these in series or sequentially. And if we kind of collapse this a bit, what you'll really see is that the series method is taking 2 parameters here. And the first parameter is an array, and it's an array of functions. And the way I like to think of async is that it is essentially extending out the Node.js style callback pattern that we always see in Node.js. So there's not a lot of learning anything new here, which is great. You can just kind of use what you already know. So async series is taking in an array of functions to be executed sequentially, followed by a function that will either A, be executed when all of these functions finish successfully, or B, when an error occurs, in which case the rest of the functions will not be executed and you'll be passed along the error that occurred instead. So you can see what I'm doing here. The first function is the one responsible then for getting the connection. So it can get the connection, and in this case, in terms of state management, rather than pass things around, which I could have done with another method like waterfall, instead of doing that, I've just decided to declare some variables up here in a higher level of scope so that other methods such as insert, header, and details can get to it. So we just assign that higher up in scope, and then we invoke this callback. This is not the callback that was passed to post, but rather this is the callback that async passed our first function. And this is the way that we let async know that it's finished, or that we're finished processing this function, and it can go ahead then and invoke the next function. So it goes ahead and does that. So with insert header, similar logic to what we saw before, only this time we just invoke the callback to signal it can proceed. We get to the details, and this is where I'm using yet another method within async, but rather than the control flow that you saw before, this is one of these methods that operates on a collection. So you're seeing an example of both of the types of functions you might be using with async. So in the case of each series, what we do is start with an array of data that we want to iterate. In this case, it's the details array in the order. A function that should be invoked once for each element in that array, And then finally, a callback, of course, that'll be invoked when either everything completes or an error occurs. And so for each iteration of this details array, this function will be invoked, and it'll pass along the actual detail or single row within the element, as well as another callback that we invoke to tell async to go to yet the next element in the array. And so you kind of see how async is working here. It's all just based on passing these callbacks so that we can signal when the async engine should continue to the next unit of work. At the very end here, you see I'm committing a transaction, and then finally this function runs, closes the connection, and we're done. We can pass back that header ID. So that's the async module. Someone commented in the chat, was them I was working with, but they're using Node 6, so no async support. So actually, what I'm looking at here is called the Async Module. And in two examples from here, I'm going to get to what you're referring to, which is the native async function support in JavaScript, which is also known as async await. But in terms of this, what this is, this is a module called async. So I said I wouldn't run this test, but I guess I will. What I'm going to do is delete async, and I'm going to say run the third test, and we're getting an error here because the async module does not exist. So even if you were in Node 6 here, all you have to do is an npm install async, typically followed with a save command. It'll go out, it'll pull that in, and we can rerun the test, and now you see it succeed. So this is one of those things that you really don't have to wait for a later version of Node for. And believe me, even when you learn some of the concepts that I'll show you here in a moment, you still don't want to forget about this module, because although there's now built-in async await and this kind of stuff and promises and all that, that's nice, but this module is still incredibly powerful and useful, and you'll find yourself coming back to it when you're doing really complex flows. Maybe not the simple stuff anymore, as we're working with here, right, a header detail, but for complex stuff, when you're thinking, maybe I need a queue or something like that, then async is still really, really handy. All right, so the good, fixed our problem with nesting. We can work with collections really easily. And on the bad, is this yet just another form of callback hell? Perhaps, perhaps not. It depends on how you look at it. All right, so let's move on, and we'll talk about the next thing that I think most Node developers get into. Once they're comfortable with async processing and really the the default Node.js style callbacks, then they can take on promises. This is sort of like, you have to do one before the next. You have to crawl before you can walk and walk before you can run. But once you've really mastered callbacks, then I think you're ready to move on to promises. And so promises started actually a long time ago in sort of user land. There were lots of modules. I think Bluebird is perhaps one of the most popular examples of these modules. It's actually still used quite heavily today. But eventually the spec, it became a reality as part of the language. And so promise support is now built in. You don't have to do anything to include it. And in fact, one of the things I liked when they added support for promises was the simpler implementation, if you will, than you might have seen previous to that working with the third-party modules. So the way it works when you start working with promises, you're starting to work with objects that can have one of three states, either pending, resolved, or rejected. And you can chain promises together, which can make for really nice, clean code without having to nest too much. And you can chain using then and catch methods, which we'll take a look at. And you can use then and catch in a similar pattern as you might have in JavaScript with try catch, which wasn't really possible in JavaScript, but you can do it here with the async module. or rather with promises. So here you're seeing the header detail example, the 30,000 foot overview, and this is kind of what it looks like. Now on line 8 here, what we're looking at is a call to the driver's get connection method. And if you look at previous examples of that same call, you'll notice that it accepted a callback function. And when you passed along a callback function, then it would not return a promise. But here what you're seeing is the first time we're using it and expecting it to return a promise. So all of the driver's asynchronous methods, so get connection, create pool, execute, commit, all of those are overloaded such that if you do not pass a callback function, it will go ahead then and return a promise. Question in the queue is, are these examples going to be shared? Absolutely. I will make sure to share them immediately after the talk. So what we're doing here is invoking get connection. Let me get into the code actually. So you see here, in fact, this is the first example. All of the previous examples, the post function took a callback function. In other words, because we were exploring different patterns with the callback patterns, the post API that we had exposed to the test file itself accepted a callback. But when we move now into promises, what you see is the API itself is no longer accepting a callback. The idea being, of course, that if you're all in with promises, all of your APIs are going to be promise-based. So you're seeing here an example of what a promise-based API would look like. So in this case, the post function is taken in the order to be created. And let's collapse this in. And you can see rather clearly here now what the post is really doing is simply returning a new instance of a promise. And when you create a new promise, you're going to pass in what's called a resolver function. And this function is going to have 2 parameters passed to it when it's run, resolve and reject. And it's up to you, the implementer of the API, to invoke one of these 2 functions. And you're going to invoke resolve when everything completes successfully. And you're going to invoke reject if something goes wrong within your execution of the function. So we'll open this up. And you'll see that, like before, I'm going to the driver and getting out a connection. And what I do is I chain off of that. So what's happening here is get connection is returning a promise. And when it returns that promise, immediately it's in the pending state. It's not resolved yet or rejected, but I can use then to wait before I continue to the next step. Sorry, there's a question in the queue. When does it make sense to use the Node driver to connect to Oracle? When does it make sense to use REST or ORDs? It's a good question. I think it may come down to sort of your comfort level with languages. So for example, if you're a longtime Oracle Database developer, comfortable with SQL and PL SQL, I think it would be a perfectly good choice to go with ORDs, Oracle REST Data Services, because it's not going to be anything really new to learn. ORDs handles a lot of the underlying plumbing for you. However, if you're a JavaScript developer, or if you prefer like a lower level of control, then oftentimes drivers and language-specific drivers that you're comfortable with are going to be a better choice.
I think the official answer is it never makes sense to use ORDs. This is
Maybe not to a JavaScript group. Certainly not.
No, that's not true. It certainly has a place. It's one of those things where you then rely on other people to start doing infrastructure setup for you, whereas things like Node and Python, whatever, you can pretty much just get on with and do yourself. So there are sort of pros and cons in terms of the administration as well. You get differences in terms of security models. You're not going to be using ORDs for data loading. We've seen a lot of people trying to do data loading, insert large volumes of data, so you're not going to be using that, using REST and ORDs. We've already had questions here today about the failover and fast connection, stuff like that. You know, I think you'll see definite advantages there if you can spread your mid-tiers out. So your Node as the mid-tier, so you can spread those out in terms of reliability. So pretty obvious. Some of the cases, and the rest, as Dan says, are almost business decisions plus your comfort level. Mm-hmm. Use the right tool for the job.
Exactly. That's always a good thing to do. Thanks, Chris. All right, back on the promises. So what we have here is a function returning a promise. I'm chaining off of that promise with then, and something magical happens with then. When you either use then or catch, you're passing a callback function. So with promises, by the way, you can't escape callback functions. Surprise, surprise, you'll never escape them in JavaScript. But what we're doing is passing a callback function to then. But this callback function will not be executed until the promise that was returned from getConnection is either resolved or rejected. And to get to the then path, it would have to be resolved. Then our function is going to be invoked. And when it is, it will be supplied the connection that was created as a result of the getConnection method succeeding. Now, inside of the body, what I'm doing here is I'm returning the result of a call to connection.execute. And as I mentioned, all of our async methods are overloaded so that if you don't pass a callback function, and you do not see one here, it will return a promise. So within the then block, I'm returning a promise. So the next then block will not execute until that promise is resolved. This is a little bit of black magic. It's just kind of handling some of this stuff for us, but it is definitely convenient. Now, what you're seeing right here is my biggest gripe with promises. And remember, we had this scenario where we have 3 detail records. And what we need to do is, of course, do a single insert for each of the 3. And you see what this looks like with promises. So to do a promise chain, what you first have to do is kickstart things by invoking promise.resolve. This just gives you a resolved promise. And then I'm coming in here and I'm using a for each loop on the details array. So this is a synchronous loop. So I'm looping 3 times in the current call stack, and I'm setting promise chain equal to itself, and then I'm chaining the then call, making another, like then on top. So I personally find this to be really confusing. It does work, but I'm definitely not a fan of this pattern here. I think it's overly complex. And just going back to the async module where we were inserting the detail rows, I think async clearly wins here. You know, saying each series, this is the array we want to iterate, this is the function that should be executed once for each element in the array, is definitely far better than winding up a promise chain that you're then going to unwind via this return call here. This is going to make sure that all 3 of the inserts succeed before continuing on to the next then call. Question in the queue: is there an advantage of naming those callbacks as opposed to keeping them as asynchronous? So the named callbacks here that you see, it's not as opposed to asynchronous. Oh, no, sorry, you said anonymous. I said asynchronous. Yes, you said it correctly. So aside from documentation, no, there's no advantage. These could definitely be anonymous functions. There used to be some issues with respect to logging. If you only had asynchronous functions and your error output log, you'd get an anonymous function as opposed to a named function. You wouldn't maybe know where to look, but I believe that's no longer the case. So no, there's really no benefit other than maybe self-documenting code, if you will. All right, coming down a bit further, what we see here is the first example where then is taking 2 callbacks. So the first is what you saw before. It is the callback that will be invoked upon the successful completion of the previous operation, in this case, all of those inserts succeeding. If that succeeds, then we can go ahead and commit the transaction. The second callback function here is for an error path. So then can actually be used both for success and error if you do pass 2 callback functions, or you could just use catch to just catch a single one. In this case, I just want to show an example, and in fact, this flow lends itself well to this splitting up in a single handler. So I'm using commit here. This is the first time you're seeing an explicit rollback, and then I'm going to reject that promise because something failed. I'm not resolving it yet until finally we close the connection. I could have resolved it up there. It's really not a problem. Note that when you close the connection, I'm returning out the promise returned from that. It's possible an error would have occurred during the close. So I go ahead then and catch any errors that could have occurred. This is really important when you're building promise chains. Make sure you have a catch on the end if there's anything that could have gone wrong prior to that step. Especially in later versions of Node, they're just going to stop masking uncaught errors. And so you could kill the Node app. The main thread could die when they stop masking that fact for you. So you definitely want to do that. Couple of questions in the queue here. So there's a comment. Most folks, with respect to these anonymous callback functions, tend now to use ECMAScript 6 arrow style functions. Totally agree. I tend to avoid them, if only to make the code a bit clearer to folks that are not yet at that level, because I kind of see this as getting more and more abstract over time. And so I think sometimes JavaScript code today looks almost mysterious, like how in the world is this stuff working? So I like to use some of the older constructs still for folks that are on that learning path. Couldn't you use promise all, orders map order, execute or similar to build the chain? That is an interesting question. So I spent a lot of my time in the forum trying to help people work through asynchronous code and debug issues. Anytime I start to see promise all and orders map, I start to wonder if there's an issue. And in fact, we were kind of debugging through one today. The idea is you want to keep control of your code in the JavaScript layer. And it's very easy in Node to kind of take a bunch of work. And unfortunately, my images weren't working earlier. But when you're doing different types of work, you can either maintain control in the main event loop in your JavaScript code via queues and the type of code I have written here. Or you can take a unit of work, let's say inserting 3 detail records, and you can throw that over the queue to libuv, where it has its background threads and a queue in front of the background threads. Now here's the thing. This connection can only do one thing at a time. So if you do a loop, a synchronous loop here, and you're saying con.execute 3 times this insert statement, or let's imagine, in fact, that the details here, not 3 rows, but 1,000,000 rows, if you will, right? So we're saying, okay, for 1,000,000 times, do a synchronous loop, and we call execute insert. Well, what's going to happen is 1,000,000 different calls are going to go over to libuv, and they're going to be queued up for work. Now let's imagine that the very first of those 1,000,000 rows fails. Well, the transaction's obviously going to be rolled back, right? There's no need to process any of the other 999,000 rows. And yet, because you've passed them over, you can't get them back. They're all going to have to fail before you can go ahead and do your rollback. So the idea is you really want to maintain control of your code, and that's why you have to keep it in the main event loop. If you're using promise all, I'm not saying it's not impossible to use that right, but you have to think through what you're doing in order to do so. So another comment in the queue, a single connection, it would be synchronous. In the end, connections can't, yep, exactly, that's correct, good point. Also, I don't think you need a new outer promise, but can return the main promise chain. So that's a fair point. Let me see here. I could, in this particular example, return the main promise chain. The advantage of wrapping, if you will, just lends itself to some control when needed. But in this particular case, as long as you have the catch on the end here, yeah, it should unwind itself just fine. Yep, that's a fair point. I think I got called out on that today in the forum as well. All right, let's move on to the next pattern. And actually, I guess the last we're going to have time to look at today. So this is when we get into async await. And as I mentioned before, you really do have to spend some time sort of mastering callbacks before you move on to promises. And you really have to spend some time before you move on to this next thing, which are async functions, also known as async await. So basically, we got some new keywords in JavaScript. And they came in, they were inherited from V8. They're supported in Node 7.6 and above. And the new keyword that you start with is async. And you just put this in front of a function declaration. And then you have access to the await keyword within the body of that async function. And what ends up happening is sort of like black magic, but basically you can put await in front of a function that returns a promise. And the processing within the async function will stop. It will not continue until the promise is resolved. And then basically control comes back to that thread and it continues on as though it was synchronous in nature. So it helps us sort of unwind some of our code and write code as though it were synchronous, although it's still executing as it always had before. So here's that 30,000-foot overview of the solution written using async await. What you're seeing here is a construct that in the beginning, I like to point out, does not work with async functions, and that's the try, catch, finally block. This is how you might see code typically written in a language like Java that is connecting to a database, using the connection to do some work, and eventually releasing the connection. Whether or not an error occurs, you want to release the connection oftentimes in the finally block. It's a nice, clean way to structure your code and one of the most popular uses of try, catch, finally. You can't use it in JavaScript when doing async work until you get into this async function here. So with async functions, all of a sudden, constructs that did not make sense before, such as try, catch, such as looping, a synchronous loop, now you can do asynchronous for loops. All of a sudden, the language, the features that you wanted to use asynchronously before, you all of a sudden can. Let's take a look at this pattern. And what you see here is our try block. And so note that if an error occurs, I'm just saying await con rollback. And then finally, we go ahead and close that connection. So this is that single place where I'm going to close that connection. But the bulk of the work is going to be done within the try. So I put the async keyword in front of the function that makes post an async function. And one of the nice things about async functions is that by default, they're going to return a promise. So you don't need to do any of that, custom return a promise. It's handled for you by default. And so in our try block, I'm using the await keyword because we know that get connection returns a promise. So literally what's going to happen in terms of the execution of this code, the thread will stop here. It will process this asynchronously. And then if it succeeds and gets a connection, it will come back to our thread, return the result of the promise to this con array here, and then continue on with the processing as though it had never left before. And this is a concept known as coroutines. It's something that's been available in JavaScript for a long time now via generators and whatnot. But I think only now with async await, this capability is now fairly usable by mere mortals such as myself. So we get our connection, and then we can use it to do the insert into the header record. And note how clean the code is starting to get here. Get a connection. No nesting. We can say, all right, now use the connection to do something like insert a header row. The result of that call will be here. We can then use that to get our header ID. And now here's something really neat. What you're seeing is a loop that previously would have been a synchronous loop, but simply by putting the await keyword in front of the execute call, this does in fact become an asynchronous loop. So if the first iteration of this loop fails, none of the other elements in this array will be processed. Immediately we'll drop down into the catch block. But if everything succeeds, we can go ahead and commit. And note that I'm returning this header ID rather than resolving it as you would have seen in the promise example. I'm returning this out, and it goes ahead then and resolves that in the outer scope of the promise for you. And I think that's really it that's going on here with the try, catch, finally. So this is definitely where I think folks should be heading. As somebody commented already, they're currently using Node 6 something, and so they don't have it available to them. So that's a bummer. Hopefully you'll be moving over to Node 8 or above in the near future, where you can start to make use of this technology. So I already talked about the good and the bad. Just keep in mind that you really do have to have still, I think, a good understanding of promises in order to make good use of these. I'll just point out, and maybe we'll have time to get into this in the next session, but Node does support streams out of the box, so I'll just move quickly through these last, and we'll do some examples in the next session. There are 4 different classes for streams out of the box: readable, writable, duplex, and stream. And there's, as you would expect with something like a stream object, built-in support for things like buffering and back pressure to make sure that the streams are working efficiently. And we do support streams out of the box. Here you're seeing an example of query stream, which is going to return a read consistent view of the data. So with respect to the point in time the query was executed, but rather than give you the result set, which is often how we process these, you can get back a query stream and process the array using this object. Just set up your event handlers, and then you can handle that, the data coming in. Alternatively, you can pipe streams, so you can kind of compose. You can take a write stream from a file and a read stream here, like select star from emp, and you can stream the read stream into the write stream, writing it directly to the file. You can do different combinations, introduce transform streams in the middle. It's a really nice way to simplify some of the code. One other library I'll point out that's gaining some attention is Rxjs, and this is the reactive X extensions for JavaScript. This is a pattern or a library that's sort of available in lots of different languages and to varying degrees, but it is supported in JavaScript as well. A lot of useful operators, similar in a way to what we saw with the Async module, but different in useful patterns. So things like delay and retry, if you're on networks that maybe aren't as reliable as you'd like them to be, maybe you want to build in some really easy retry logic, you can certainly do that with Rxjs. And I don't have any of my slides, but that's all right. It's 4 o'clock anyway. So I'll just say thank you to everybody for joining. If you have any questions, feel free to stick around, and we'll just address them as they come into the queue. Hopefully we'll see you next month for the next session. And as I said, we'll at least finish working with maybe some stream examples and that kind of stuff, and then we'll go on to another topic.
And speaking of other topics, if anybody has any suggestions, favorites, whatever they want to talk about, just throw it out there and we'll try and do that as the sort of icebreaker.
Somebody wants to, cover some clobs.
Okay. Yeah, we can do clobs. Don't forget to read the manual on clobs. There's a lot of stuff in there. There are almost 2 kinds of clobs, huge clobs and normal clobs. So yeah, we can certainly discuss that.
Is the idea to stream a clob to a file or stream a clob across a network request? How did you want to handle that?
And we can unmute you if you want to talk.
Hey guys, can you hear me?
Yep.
Yeah. Oh, good. Yeah.
Yeah, with respect to Lobs, I was following the documentation, and basically what I implemented was utilizing the returning into in the SQL code to outbind that whatever I'm transferring into the CLOB field.
Mm-hmm.
I was wondering if there's a way, instead of using that returning into and targeting the outbind, is there a way to just create like an empty CLOB object and then stream it straight in there before I commit it?
Yeah, we have a thing called temporary lobs, which you can create. There's a create lob method in Node Oracle DB, so you can create a temporary lob and stream into that and then insert it into the database. However, that uses temporary table space in the database, so I think it's actually going to be less efficient.
Oh, really? Okay.
Than using the create lob and getting the lob locator and then streaming into the lob locator.
And if you have
Go ahead, Anthony. Yep.
Oh, I was just going to say, if you have the full string already available, you can also just insert the string directly.
Yeah, for sort of the small lob sizes, the few megabytes, etc. use the
I
string
think that's
method is
what
going to be
the issue I
faster.
ran into is it was hitting the cap, and that's why
Yeah.
I went into the CLOB territory there.
Yeah, so it's really a matter of tuning. Temporary lobs also have one little quirk, which amongst friends here, as we are speaking technically, you need to make sure that you close them properly before you get rid of the connection. Although I think Anthony's done some work there, but to try and track that. But traditionally they weren't released at the end of connection. So unless you're using the later versions of Node Oracle DB, then you need definitely to make sure that you're following the documentation on closing the temporary lobs before you close connections. Otherwise, you could end up with lob leaks and run out of temporary table space.
Oh, okay.
Anthony did a lot of work in the underlying layers of the data access code stuff, the thing we call ODPI. That sort of common layer we're using now for a couple of the database drivers, and then we've got other people using it for Rust drivers and Haskell and Go drivers and things like that. But he's done a lot of reference counting work there to try and just make that all work for you. So certainly in this latest release 2.1 of Node Oracle DB, then you can pretty much do what I mean, and it'll take care of it for you.
Sweet. I have a question for Dan, actually.
Yeah.
Feel free to say no, but can you show me an example of using the async module's queue method? I've never had any interaction with that module before, and I wasn't sure what you meant.
Yeah, what we might do is just take a peek at their doc and see what example they have up there. I meant actually to have one together today, and I can certainly do that for next time. We can take a look at some stream examples and queue examples as well. But the way this works, when you come to their page, they have all their doc on GitHub.io. So you just want to click this link here to skip over to that. And that's one of the control flow examples.
Yeah, it's right there in the middle there.
Is it?
Yeah.
There it is. Thanks. I'd have found it eventually. All right, so let's see if we can break this down, see what it's doing. So Async Queue. One of the things that makes it really easy is the second parameter here is the queue concurrency. So Async can go ahead and monitor, for example, how many of these functions are running at any given point in time, and you can adjust that as needed. So we're saying, all right, it's going to do this work and eventually invoke this callback. Then they take the queue and they add some data to it. So it's just going to start processing using this function. It's essentially that it really is that simple. And in the case of the driver, what you might do in terms of where data is coming into the queue, it could be from a file, in which case you might be using a streamer to convert a very large file into a readable stream. And then as the stream is emitting events or rows, you could be pushing the data then into a queue. Or you might be reading the data rather than from a file. It might be streaming in from a database using either the query stream or the former object. Anthony, I'm blanking here. What's it called? The result set. So you could either use either of those objects, but in any case, as data is coming in then from the database, you're pushing that into the queue and just letting this little function here handle it for you. If that's not enough, let me ask you this. Do you have a general kind of use case where you want to use it, and I can make sure to have an example ready for you for next time?
Yeah, it was the one you were going back and forth with the last few days about the connection queue issue.
Mm-hmm. Where is your data coming from, by the way? You're working with up to 400,000 records at a time, right?
Yeah, it's coming from this reporting API. Basically, I work with the database marketing team here, and for each campaign we sent out, we need contact level reporting back. Mm-hmm. And we aggregate them into our Oracle database. So it's those result sets that I was having issues with managing connections.
So when you say it comes from an API. You're actually issuing a network request saying, hey, give me these rows. They are returning 400,000 rows to you, and then you want to move that into Oracle Database. Is that fair?
Yeah.
Got it. Okay. And when they're returning the data, are they returning it to you as a stream, or are they materializing the result set and then you're having to process that as one giant chunk?
They chunk it basically.
Excellent.
Yeah.
Fantastic. Okay. So I can definitely put together an example for you that would basically emulate those various touch points, consuming an API that's streamable, and then moving that data into a queue, and then processing it as a queue. The difficulty, I think, and I mentioned this with what you're doing, the biggest thing that I struggle with is using multiple connections and sort of having each one commit, because we're reading this, up to 400,000 rows, and then we're calling some individual connections to do the insert work. And if any one of those fails, we have no longer the ability to roll back the transaction as a single unit of work. So I mentioned that there before, and it doesn't seem to be so much an issue for you.
Yeah.
For some folks, it may be.
Sorry, as a business rule, we sort of we address that as a business rule, saying, do we want partial reporting data coming back, or do we want sort of like an all or none type of deal? And since we're running it pretty much daily, I think we sort of said having partial data at any given point of time is okay, as long as it's within 7 days. So within 7 days, we would need the full result set. But if one of the batches fail to insert at any given point of time, it's okay. So that's why I treated them. I basically parallelized the connection. So for each 10,000, treat it as a transaction, and if that transaction fail, it's okay as a business rule.
But you must be materializing the data as it comes across the network somewhat up to those arrays of 10,000 rows. Is that right?
Yeah.
Uh-huh. You know what may be interesting for you is, rather than buffering up to 10,000, actually, I kind of like the fact that you're doing that. I kind of see why you're doing that. You may not notice much of a performance difference if you did go down to a single connection.
Really?
Have you experimented with that?
I haven't. I mean, the easy fix is I can just send the batch size into whatever the full result set, and just do a single connection. I can try it right now, actually.
I would say to give it a shot, because something's telling me you're not going to notice that big of a difference, because your producer here is not reading a local file, which of course can generate data much faster. You're already coming across the wire, right?
Yeah.
And so you're acting as your own buffering agent, and you're doing it in groups of 10,000. Sending that across to Oracle is a single round trip. And so while you may be buffering a bit more than 10,000, I don't know if it'd be a whole lot more. It's certainly worth a shot. And then you can always say, well, hey, it didn't perform the way we wanted it to, so we're willing to sacrifice the transaction control. But if it does work fast enough, why not keep that transaction control? That might work better for you.
Cool. I'll give that a try.
So we've definitely talked about implementing batch DML in Node Oracle DB to make it easier to more efficiently insert and update records in the database. We just have this huge queue of work and things we want to do. Obviously, we're looking after other drivers. We mentioned the Python and ODPI, and we've also got PHP, etc. there. And so, although that's kind of high up the list, I really don't have any time frame for when that's gonna get in. Sorry about that, but we are aware that it would be useful for you.
Let us know how that experiment goes. I'd be curious. Are there any other questions?
Any other high priority wish list items for the driver for Node Oracle DB for people using that?
CQN. AQ. That wasn't me.
Yeah, I mean, everybody has a different use case, and so it's just interesting. Do people want to do binding of objects? Do people want call timeouts? We're seeing pushes for sharding support. And some of it's simpler than others to do. Some of it's just a pass through to the OCI layer. Other things, because OCI, that's the Oracle call interface, has a lot of modes, we have to kind of sit back and really evaluate what's the the 80-20 rule, what's the most requested bit, so we don't just overload everybody with 1,000 options. And then we are trying to think about some futures as well in the database and just try to make sure we're sort of simplifying things rather than making it complex and getting rid of stuff. So let me just continue talking. So there are a couple of questions there from Danilo about hosting packages. I'm just going to share my screen. I don't know what's underneath. I'm going to steal it from you, Dan.
Please.
And I'm going to share, which screen desktop 1 will do. And I can't see where the question has got to. Get out of here. Okay, I can't see the questions pop up anymore for whatever reasons. It's just gone blank on that half of the screen. So yell out if there are any questions pop up. So the bottom line is that that some people do want to self-host packages, and we have this directory in the source code called package, which is the one that we use when we're building the binary packages, which we stick that up there on GitHub. So there are kind of a couple of components when you do the install nowadays in the version 2 of Node Oracle DB. There's this sort of generic package, top-level package, which is hosted on the NPM repository and on Yarn and places like that. And that just has the JavaScript files, but no binaries. But it has an install target. So when this gets unpackaged by NPM, the install target tries to go and download a suitable binary for whichever version of Node and version of Node Oracle DB and platform, et cetera, et cetera. So there are two components there, and there's a make file in this directory, which I can show you, which actually we just use, and a couple of targets there. The dependency checking is not the best, but it works. Pull requests welcome, and effectively you're going to get out 3 variants of top-level packages, plus then you can get the binary packages as well, separate one for each platform. So by magic of setting a couple of environment variables, the difference between this, what we call the sort of generic package, which is the one that you're using when you do your production installs, and this one we use for internal testing, is really just where it goes to look for those binaries when it downloads the binaries with that install target. And so you can just set a couple of environment variables before you run make or before you build this package, and that will determine where this package is going to look for binary packages. So you run npm package, you run make binary package for whichever platforms you want, and as long as you have these couple of environment variables set before you do all of that, then you're going to end up with a staging file, and you can call this anything, you can move this anywhere, and then just add this to your dependencies in your package.json file. And that would then install a couple of quirks there to get the plumbing right in terms of where it's looking, but that's pretty much it. Did any other questions pop up on the Zoom, which, as I say, has kind of gone blank on the right-hand side for me?
No, not yet. I did want to just mention or ask rather. I believe it was Sandis that I was talking with before about the queuing. One more idea just occurred to me, and I've done this in the past, where when you make that HTTP request and you're ingesting that data, have you actually worked with that as a stream and tried calling pause on your incoming request?
I haven't actually, no.
So I've done that myself in the past, where that kind of goes back to the built-in back pressure when we're talking about streaming or piping streams. It's sort of something you get for free, but if you do need to drop down to lower levels, the Node Stream APIs expose methods such as pause and resume. And literally at the HTTP layer, you can sort of pause a stream and signal upstream that they shouldn't send you more data yet. That may also be worth exploring if you find using a single connection, maybe you're trying to buffer in sets of 10,000 and it's getting up to 20, 30, 100,000. You can't push it to Oracle fast enough. maybe just try adding a few pauses until you get back, drop a note beneath a certain threshold. So then you're doing the buffering yourself. That may also work for you.
I didn't think of that. I'll definitely give that a try. Thanks a lot, Dan.
Cool. Okay, any other questions?
Actually, I will just go back to the question there I see about this install again. So the question, just to clarify, is you can build pretty much binaries for any platform architecture that you like, not just Linux 64 or Node 6 or anything like that. We personally inside Oracle only push out 64-bit binaries just because it's, there's too much choice out there. We have to limit it somehow. Everybody's going to 64-bit. But if you're running on 32-bit, those make binary packages will still work.
Somebody asked me how Rxjs compares to other things. Would I use it? Would I not? Let me just show you something real quick on that. This is one of the websites I find myself going to from time to time. This is npm stat. And it looks a little crazy until you get maybe down to here where you're looking at weekly downloads or monthly downloads. But this just kind of shows you when you compare the async module to Rxjs, there's definitely some increased attention on Rxjs, without a doubt. But the number of folks using async compared to Rxjs is just far greater. And so my suggestion would be to start with callbacks, including async module, then get into promises and then async await. And if you find yourself in a situation that requires Rxjs, maybe give it a shot. But I will say most folks, it's a fairly different way of thinking. It's going to kind of turn things around in a way that you may not be ready for. And I would say that most folks aren't going to use it for the little handy-dandy thing they need every once in a while, like they might do with async, but rather they're going to entirely reshape their application to be using this Async or Rxjs paradigm. So it's not a small deal. It's usually a bigger deal, and it's like a complete application rewrite. Doesn't mean it's not worth doing. It's just it's not as trivial as bringing in async for a thing or two.
Sorry for that key clicking. I was not on mute. Just trying to check out that stats site. Looks really good.
Cool. All right. Well, I do not see any more questions. So I guess we'll go ahead and call it there. Just say thanks again to everybody for joining, and hopefully we'll see you in about another month.
Thanks, Dan. Thanks very much.
Bye, everyone. Take care.
See ya. Bye-bye.
Bye-bye.
Bye.